Here we go. You become bigger, so that way you don't get any DMCA vibe, which I'll also can learn. It comes to pick background audio. Then select one or multiple tracks on the left of your studio, indicating your stream. After you've added channel, multiple tracks in your list queue. We also have experience, including the ability to play a track before going live or during your stream. Sharing will continue. Best tools we at our email thing on bigger and better with no.
What's up, fam? It's your boy Kirk Nugent, and I'm excited to be 5 Panther in a blog in for you to check that out. Those are for my window and get into what we're about to do here. And you want to make sure you have these settings set right for your system. Now we have that set. I'm going to go ahead and enter the studio, select a video. Now, songs that you know up on screen right now, this is automatically to the stream. Add the video to the stream. Supposed to be background music. Now, here I have any effect. And listen, it's all in the software. It's all in the platform. We haven't pulled any tricks out of our sleeves. That's all you've got to do in terms of prep work is make sure you have a video that has non-copyrighted music in it that you can add to the stream and use one of those layouts that doesn't display the video. Man, it has been my absolute pleasure to be here with you for these videos. Drop us some messages in the comments. Let us know how you have been using music in your live streams. We want to hear from you. And if you haven't already, make sure you like, share, and subscribe. StreamYard is literally churning out all kinds of content, all kinds of live shows that has a ton of value, and we want to make sure that you're aware of that and that you can take advantage of it, because this is all this channel is here for. So it's your boy Kirk Nugent, Geek Speaker Preacher, excited about this partnership with StreamYard, excited about the content that we're going to create together here in this space, and I'm excited to see you in another video. Later.
Hoe kom jij voordelig de vakantie door? Je had net een goede tip.
Maar je bedoelt die theezakjes?
Ja, vertel eens.
Dan denk je, nou, er komt nog een beetje kleur af, dus hij kan nog wel een keer.
Of je koopt de aanbiedingen bij Dirk. Met deze week een flacon Robijn wasmiddel voor maar €3,99. Op Dirk kun je rekenen.
Zakelijk internet van T-Mobile. Nu de eerste 8 maanden voor maar €25 per maand. Met Google Chromecast 4K plus NL Ziet Extra cadeau. Want er zijn weer go-go-go deals voor ondernemers. Check t-mobile.nl/ondernemen.
Welcome to this tutorial on how to create the ultimate Excel Gantt chart for project management. A Gantt chart is arguably the most widely used project planning tool, and Excel allows you to quickly set up a simple Gantt chart, but you can also build a really outstanding version with many advanced and interactive features, making this a professional project planning and management tool. Let's take a quick look at the final Excel template that we're gonna build today. It allows you to set up an advanced and workday-focused project schedule consisting of project stages with task and milestone items. Setting up a schedule for these items is as easy as defining the number of required workdays and then either entering an independent start or end date manually or making use of the core feature of this template, a fully implemented dependency engine. With this dependency engine, you can make one item dependent on another one by creating a connection through an intuitive ID system. The columns next to the referenced ID instantly display all the fundamental information about the referenced item, and what makes this feature so incredibly powerful, there are 4 possible dependency connection types to choose from, which are either a forward scheduling finish to start or start to start dependency, or a backward scheduling start to finish or finish to finish dependency. Notice how both the stage bar and the project timespan instantly adapt to the changes made. The way this dependency engine is built enables you to set up consecutive dependencies with different dependency connection types in a matter of seconds. Any new task or milestone item you add below a stage is instantly assigned to that stage via an automated stage ID system. The same way, you can quickly create a new stage with its own items. Notice how the whole area and the item names are automatically formatted and structured based on the selection you make. What is really amazing, with this dependency engine, you are not limited to creating dependencies within a stage, you can also make stages dependent on other stages. For a forward-oriented stage dependency, for example, you only have to make the initial item in your stage dependent on another stage. Then, a set of standardized formulas allows you to make the stage update based on its items. And finally, you can make the other items consecutively dependent on that initial item, define the number of workdays, and make sure that the milestone ends together with the preceding task. After that, it will only take seconds to add another consecutive stage that will have the same forward scheduling dependencies with the stage start date tied to the other stage, and thus making the time span grow into the future whenever the number of required workdays is increased. In case you want to flip this into a backward scheduled stage dependency with the stage end date tied to the preceding stage, you can simply reverse the dependency logic by rearranging the linked IDs via drag and drop and updating the dependency connection types in the respective drop-down selections. And now, the more the number of workdays is increased, the earlier the stage has to start. You see, this dependency engine enables you to quickly set up and modify a fully dynamic project schedule and always ensures that a change somewhere in the schedule will make all the dependent items instantly update. In addition, you might have noticed that every stage automatically gets colored with one color group per stage and different color shades for the stage, the tasks, and the milestone symbol. This is made possible through an automated coloring engine that dynamically creates and applies color codes in the background depending on which color mode is currently selected. Whenever the color mode project structure is selected, the colors are automatically assigned based on the stage ID and the type of item. The available color palette covers 8 different color groups that are applied in an infinite loop to ensure that you can add an unlimited amount of stages. The Team Roles color mode allows you to visualize the project based on the respective role that the project team members that are responsible for an item got assigned. Right now, only the project manager C. Miller is available here, but once we open the settings area, we get access to an incredibly powerful project role and team management system. This system allows you to add an unlimited amount of team members to your project and group them into up to 8 roles, which can be based on responsibilities, department, or whatever makes sense in your specific case. To add new roles to the project, you only need to enter the role name and provide a shortcode. After that, you can add new team members and assign any of the roles that you have just defined on the left. The assignment of roles is automatically tracked in the count column of the role type section. And once you have added your team members to the list, you can jump back to the Gantt worksheet and assign any of the defined team members to your tasks and milestones. The respective role is then automatically displayed and visualized with its own individual color in the Gantt chart. As this coloring is purely based on the project roles and not on individual team members, a team member can easily be replaced by another team member of the same role without any visual disruption. Eventually, in Issues color mode, every item that gets marked with an issue symbol is highlighted in a warning red color, and of course you have always the option to deactivate all the coloring by switching into the default color mode. Once you have set up your project schedule, you might want to keep track of the adjustments that you make to that schedule over time. You can document the date of the latest update to the actual project plan, and then, in order to preserve a snapshot of that plan, open the base plan section. Taking a snapshot is as easy as copying over the start and end date column as values, and then documenting the snapshot date. And then when time passes by and you make changes to your actual plan, like for example postponing the project start, you now have the actual plan and the original base plan side by side. And you can easily visualize the comparison of both by changing the display mode to the plan versus base comparison. That mode instantly reveals shifted dates and change durations while making sure that the timeline dates perfectly adjust to display both schedules at the same time. Of course, this template also allows you to keep track of the stage, task, and milestone completion. Once you set Show Progress to Yes, the percentage completed is beautifully visualized as a filled bar for the stages and tasks, and as a finish flag symbol for completed milestones. You can even make the completion of milestones conditionally based on the completion of one or multiple tasks, so that the milestone is automatically completed not before the linked task has reached the full 100%. In addition, a standardized formula allows you to automatically update the stage progress based on its items. Eventually, this completion tracking feature is perfectly complemented by the date highlighting option, which allows you to either dynamically highlight today and make overdue items before that line instantly catch your eyes, or alternatively, you can statically highlight any of the dates that are visible in the timeline, and these selectable timeline dates are immediately updated in the drop-down list whenever you scroll the whole Gantt chart area to the right or left, which might be especially helpful for projects of longer duration. The whole worksheet is just an amazing tool to set up fully dynamic and easy to manage project schedules. It is created with a focus on lightweight design, outstanding user experience, and fast performance. We're gonna build the whole Ultimate Excel Gantt chart template with all these amazing features step by step. The final template file is available for download on excelfind.com. Link for that is in the description. And now, without further ado, let's get right into it. As the initial step, we need to set up the general design for the Gantt and settings worksheet. For the Gantt worksheet, we start by setting up the header rows for our input and Gantt chart area. We select these two rows and decrease the general text style to size 10, make it bold and aligned to the center and middle. After that, we select the range B13 to W13 and give these cells a green fill, as this is the row where we're going to put all the single column headers into. In the row above, we then create section names, starting with these first columns as the section for IDs, then the next 6 columns for the item details, then column K to T is where the actual planning will happen, while the 2 following columns will be used to preserve a snapshot of the actual plan at a certain point of time. So we're gonna call this base plan. For both these planning sections, we want to be able to document the dates of an update or the saving of a snapshot, and that's why we make use of these 2 additional rows here. Make the font for the input field a bit smaller, and just insert a placeholder date value for now. Same for the base plan section, and eventually let's add some light gray borders to these section cells. For the single column headers, we set the general font color to white and increase the row's height as we need a bit more space here. We start with naming the first columns here as ID, then SID for stage ID, and RID for role ID. All of these columns in the ID section will be automatically calculated, so let's color them according to the legend that I have prepared up there and give these cells a lighter green fill. Then the columns for the item type and description are the first actual input columns. This one will be a special column that only contains the indicator colors, so let's give that one an even brighter green fill. The next one is the column for the project roles, which will be automatically computed based on the team member selected in this column. And then as the final column in this section, we make use of the Unicode icons that I have prepared up there, and this one will be the one used to highlight issues that you have with any of your items. In the actual plan section, the most crucial columns are the last two ones, as these will be the calculated start and end date for every single item. These two columns will contain the most crucial formulas in this worksheet, and the start and end date calculation will always be based on two types of input. The first one is the number of required workdays for an item, and the second one is some sort of date. It can be either a manually entered independent start date, or an independent end date, or, and this is where the main power of this template will come from, a dependency connection to another item. Such a dependency connection will require a link to the other item's ID, based on which then some crucial information will be extracted in these two columns. And then we have one column to select the type of dependency connection, and one to potentially add a lag by which you want the item to be shifted forward or backward. For the best possible user experience, we group these date-related input columns together and make them collapsible. And finally, let's color these snapshot columns that will be used to preserve the start and end date, and make these two columns collapsible too. The last column will be used for the progress tracking, so let's put a percentage symbol in there. Now this is the perfect time to quickly adjust the size of the columns to match the expected size of input. And right after that, we can start creating the timeline area. For the timeline, we will create one dark blue row right here. And right above that, we're gonna select the cells across these 3 rows, set the fill to a light blue, make the column really tight, and then merge these 3 cells together. Set this option to rotate text up, text alignment to the top, and the font size to 8. And now we can just select the whole column and transfer this specific formatting to as many subsequent columns as we wish using the autofill function. And that's already it for the basic design of the header and timeline section here. Wonderful! For a cleaner design, let's hide the default grid lines and add a way better looking custom formatting instead. Initially, we want to visually separate the main sections, so let's hold the Ctrl key and select the respective sections, including the header rows and the number of content rows below. With all these selected, we go to the Home tab, open the Border menu and click on More Borders. This will open this Format Cells window in which we can now select a border color like this midlight gray and then specify that we want to add a left and right border. The overall spacing in this sheet here is aimed to perfectly fit into the open window with the actual planning section fully expanded and the base plan section collapsed. So let's do that. And then let's select the whole content area and add some horizontal row-wise borders with an even lighter gray. Perfect. The basic timeline design and size is already defined, so we now know the ideal position for adding a top right settings button that will let us jump straight to the settings worksheet. For the button, we merge these 6 cells, set the text alignment to center and middle, add a white border around them, and label it Settings. After that, we right-click on it and click on Link, which opens this window. As we want to create an internal link inside of the workbook, we go to Place in this document and select the Settings worksheet. We can even define a target cell, so let's choose the cell in the settings sheet where we probably gonna place the button for jumping back to the Gantt sheet later. And eventually, I recommend to also define the screen tip, which is the text displayed when hovering over the button. The addition of this link to our button has automatically changed the text format here, so let's fix this and make the text bold, not underlined, and white. Now, with the current setup, only the text itself works as a link, but not the full merged cell area. But we can easily change that by activating the Wrap Text option. And now these merged cells perfectly function like we expect a button to do. We are redirected to cell X2 on the settings worksheet and gonna recreate a similar button that leads back to the Gantt worksheet. So we add the same white borders, call it Gantt, add a link to the Gantt worksheet, cell BL2, then add a screen tip, and apply the required formatting. And now this works like a charm. We're just gonna increase the size a little bit. And there we go.
Waar je ook heen gaat, wie reist met NS kan alle kanten op. Niet alleen met de trein, maar ook met de bus. Of lekker op de OV-fiets. Of, als je sneller wil, de deelscooter. Hoe je ook reist, het begint in de NS-app. Waar ga jij naartoe vandaag?
The initial input section that we're going to create in this settings worksheet will be for some basic project details. We add some gray borders around that section and adjust the column size so that we have 2 small columns on each side acting as padding and 2 large columns for creating some input fields. Let's also hide the grid lines on the whole worksheet for a cleaner look and then create multiple input fields for the project title, the project manager, and potentially some additional information like, for example, project priority. We select all of these labels, make them bold, decrease the font size, and also add some indent and a light gray border. And then these cells are the actual input fields, which we highlight by adding a light green fill and a similar font size and indent formatting. Let's enter some example values here. The first 2 are simple text fields, and the project priority field is a good opportunity to quickly demonstrate how to set up a drop-down list as one form of data validation for a controlled list of input values. Beautiful. For now, we will reference the project title and project manager directly in the Gantt worksheet. So let's replace this title with the input value from the settings worksheet. And then let's jump over there, add a green label, and an absolute cell reference to the project manager input field. Just like the project manager, we also want to display the project time span, which includes the project start and end date, as well as the project duration. For now, we're only going to enter an example date value for the project start date and some placeholder values for the project end date and duration. But later in this tutorial, we're going to transform this into a dynamically computed time span. For now, we only need the project start date, as we need it to set up the timeline values, which basically means that we reference it as the initial date in the timeline, and of course make sure it has a clean date formatting. And then for the subsequent date in the timeline, we make use of the workday function, as we want to entirely focus on actual workdays. The workday function returns a date, which is a specified number of workdays after a given start date. So for the start date, we simply reference the initial date in the timeline, and as we just want to get the next workday here, we enter 1 for the number of days, and then copy over the date formatting. We can then fill all the subsequent cells in the timeline here with the exact same formula as we have used relative cell references. That looks pretty good. Then in the dark blue row below, we want to display the initial weekday letter of the respective date. For that, we make use of the text function, which is perfectly suited to apply a specified text pattern to a date. So let's reference the date in the cells above and specify the pattern as DDD, which returns the initial 3 weekday letters. As we are only interested in the first letter, we're gonna wrap this formula with the left function to cut off the first letter from the left. Let's just decrease the font size and add this formula to all the subsequent cells. And that perfectly demonstrates that the timeline dates really only cover the default workdays, which are Monday to Friday. Amazing! As the final step of this initial setup, I want to dynamically structure the timeline and chart area based on weeks. So I need to create a visual separation between the weeks that still is correctly displayed even if the timeline is shifted to the left or right. For that, let's create a dynamic name reference first that dynamically references the date cells in the timeline. We select the initial timeline date cell, go to the Formulas tab, and click on Define Name. The name of this reference will be simply date. We set the scope to this worksheet only, so this name reference will only be valid in this Gantt worksheet. And then we click into the reference down below, which currently is an absolute cell reference with a $sign in front of both the column and the row. By removing this $sign in front of the column letter, this name will now dynamically reference the date cell in whatever column it is called from, while the row 10 is fixed. Let me demonstrate that. When we reference the name date from this cell, it references the date cell in the same column. And when we jump over here and reference the name date from this cell, it references the date cell of this column. In a similar manner, we can also create a name that always references the next date in the timeline. All you have to know is the reference you define in the formula below will always be relative to the cell that you had selected at the moment when you have opened the define name window. That means if we now not only remove the $sign in front of the column letter, but also change the column letter from X to Y, this name now always references the date cell in the next column. A quick test shows date references the same column date, while next date references the next column's date. We can now define a simple logical test. We check if the weekday of date is greater than the weekday of next date. With the simple workday focused setup that we have in our timeline, this expression should always be true, or when multiplied with 1 it should be 1, for all the cells for which the date in the timeline is a Friday. And once we add that formula to all the cells in this row, this proves to be true. So now we can make use of this expression to dynamically structure the timeline and Gantt area using a conditional formatting rule. We select the option Use Formula to determine which cells to format and pass the formula that we have just created to identify all the cells for which we want to have a light gray right border. That's all we need. We confirm, and as you see, not only does this beautifully add a week-based structuring to this area, but it also works no matter what the start date is. And it would even work if you decided to define custom weekend days or to consider holidays in your Gantt chart. Now let's focus on the basic item details. Before we get into setting these up, let's just make this row here really small to use it as a separator between the header and content. And in addition, let's also set the font size for the whole input area to 10. One of the most crucial input columns is the type selection, as this will decide whether the item is a stage, a task, or a milestone. As we want the user to be able to select from these options, let's create a drop-down list by opening the data validation window, selecting list, and then manually entering the 3 values S for stage, T for task, and M for milestone. That way we can now quickly select any of these potential type values, and to make this drop-down selection available in each row, we use the autofill handle and simply drag it down. Let's set the text alignment to center, and now we are ready to enter some example items here. So we quickly set up one stage that is called planning, with a few task items and a final milestone. And then a second stage called implementation with a similar inner stage structure. As we need to use the values in the type column in some follow-up calculations, let's make that easy to reference by creating a dynamic name reference called type. We set the scope to this worksheet only, and this time, unlike for the date name reference, we're gonna remove the $sign in front of the row number in order to make the row dynamically change to whatever row this type name is referenced in. Any formula we're gonna use this value in will now be much easier to build and to understand. Let's use this to add a row-based visual structure to the Gantt worksheet that dynamically adjusts based on the item type selected in each row. At first, we select the whole Gantt range and add a new conditional formatting rule that is applied in every cell for which the type value in its row equals S. That means we want to particularly highlight every stage row by setting the font style to bold and adding a mid-gray border at the top and bottom. You see, this is instantly applied and beautifully highlights every row for which we select stage as the type. To even further emphasize the fact that all the tasks and milestones are sub-items of the stage, we also want their names automatically indented. For that, we create an additional conditional formatting rule for this specific column. This time we want to automatically format all cells for which the type is either T or M. And to create the indented format, we need to go to the Number tab, jump straight to the Custom category, and here comes a pretty cool trick because you can represent a text value in a cell by using the @ symbol. And then we can simply add some space characters in front of that to create the indentation. As you see, this works beautifully, and now we have a clear visualization of the hierarchical structure of our items. On top of all that, a powerful way to visualize the difference between stages and their sub-items is the indicator color column. We can quickly set up the default color indicators by adding 2 conditional formatting rules to this column. One that's applied whenever type equals S. In that case, we want to have that darker gray as the fill color. Let's just make this a bit tighter. And then we add another rule that's applied whenever the type is T or M. And that one will add a lighter gray fill color. Beautiful. For an even cleaner formatting, you can remove the border formatting for this particular column. And as the last part of the basic item details, we also want to set up another really simple column. The column that allows you to highlight issues. Here, the input selection will be pretty simple. We're gonna set the text alignment to center and then create a drop-down list that contains this one symbol. That way, you don't have to type in anything manually here. You can easily select this symbol for any item that has an issue, and once that issue is solved, just use the delete key to remove it again. Simple as that. Now, these were the basic item details for which we only had to set up either static drop-down selection or simple input fields. For the role and team member column, however, we're gonna set up a really advanced, smart and scalable role and team management system that will allow us to manage up to 8 project roles and an unlimited amount of team members in the settings area. So let's jump over to the settings worksheet and create a new section for the project role type management, which will require a total of 5 columns. Let's change the header to a different color, for example this beautiful green, and add the same gray borderlines that we already used for the project details section. Then we adjust the size of these columns to have a right and left padding and a bit more space for the input columns. Since we want to create a list in here, we need column headers for which we can simply copy over one of these labels and change the text. The first column will be for the role name, and I prefer the text to be aligned to the middle and center. Then we can just duplicate this using the autofill function and change the other headers to code, which is the column to put in a short code that represents the role, and the hash symbol for the column in which we will be automatically counting the number of team members assigned to this specific role. The role and code column are simple text input columns. So let's give them a light green background. And as the count column will be a calculated column, we just set the background to a light gray. I guess it's time to add some example roles in here. The number of input rows is intentionally limited to 8 for 2 good reasons. First of all, the key idea of these roles is to group your single team members into functional groups in order to remove complexity and get a better overview in case you have a large team. And the second reason is, for a good visualization of different roles with different colors, it is required to have a limited size of the color palette in order to keep them somehow distinguishable. The great advantage of this approach is because we will do the coloring on this role type level, with each role able to have an unlimited number of team members assigned, we could potentially add an unlimited number of team members to the whole project. That's the reason why the project team management section will contain a much larger list. The initial input column will be for the team member name, the second column for the role assignment, and then the third calculated column for automatically displaying the role shortcode. So as I said, we could potentially make this list as large as we want, but for now I'm gonna make it roughly 30 rows so that it still fits onto the screen. Eventually, to close the section at the bottom, let's add these gray borderlines. The name column just requires simple text input. But for the assigned role column, we now want to grab all the defined roles from the other section and make them available in a drop-down list. The important thing here is we want this drop-down selection to always display only exactly those values that are defined, but not the empty cell values. To create such a dynamic range reference that grows and shrinks based on the number of non-empty cells in a range, we can make use of the offset function. For those of you who are not familiar with this powerful function, I quickly demonstrate it here. The offset function always returns a range that starts at a starting reference. Then we could add a row or column offset, which we don't need in our case, but we need to define the height dynamically by counting the number of non-empty items in the maximum possible range. And for that we can use the count_a function. As you see, this perfectly returns a dynamic array with exactly all those non-empty values. And once I add another entry, the array grows accordingly. And when I remove it, the array shrinks again. We can now use this formula directly to define a data validation drop-down list. So let's open the data validation window, select list, and then for the source we use the offset function with a starting reference, then skipping the next two arguments, and then defining the height as the number of non-empty items in that range. As you see, exactly those 5 roles defined are now selectable here in every row.
Met Adradius onderneem je zonder risico en ben je verzekerd van betaling. Check nu direct of jouw klant de factuur kan betalen. Of plan een gratis adviesgesprek in met een van onze specialisten.
When we remove an entry, the drop-down selection adjusts accordingly, which is simply amazing. Eventually, for the code column here, we want to automatically display the respective shortcode based on the selected role. For such a task, Excel offers a wide range of lookup functions, but the go-to formula that I prefer and recommend is the good old index match. For those of you unfamiliar with this formula, the index function requires you to select a range from which you want a value to be returned. And then to allocate a specific value in this one column range, the second required input is a row number. And in order to get the correct row number, we can use the match function, which simply looks up a lookup value, in our case that is the assigned role, in a lookup array, which is the role column here, and it has to be an exact match. So the match function returns the correct row number for the index function, which then returns the correct shortcode. Simple as that. Now let's see what happens once we add this formula to the row below. We get an NA error, as no role is selected here. Now as this doesn't look too pretty, let's catch this error by wrapping the formula with the if_NA function, which allows us to return an alternative value in case this error occurs. Now we can add it to all the other rows, and also add some additional team members. You see, the correct code instantly appears once we assign one of the defined roles. That is amazing. The final column that we have not taken care of so far is the column to automatically count the number of team members assigned to each role. And for this one, we first check if the role cell is non-empty, because otherwise there's obviously nothing to count. And in case it is non-empty, we use the COUNTIF function to count the number of values in that role range that equals the role defined in this list. Otherwise, we simply return an empty text string. We add this formula to all rows and instantly have an overview about the role distribution. Whenever we now add a team member and assign a role, this count is updated correctly, which is great. Eventually, to give both these lists a more list-like appearance, I like to add some white separating horizontal borderlines between the cells. That looks pretty good. And now we are ready to jump straight back to the Gantt worksheet where we're gonna make use of these smart lists. Over here, we now want to be able to select a team member via a dynamic drop-down list and then automatically display the according role right next to it. Let's add this team member drop-down list by applying the same exact technique that we have used just a minute before. So again, to create a dynamic range reference, we enter the offset function with the first cell in the name column of the team member section. Then we skip the next two arguments and then use the COUNTA function to count the number of non-empty cells in the whole team member name column. Now we can easily assign the defined team members to these task and milestone items. And in order to automatically display their respective role, we only need to look up the selected name in the project team member list and return the role shortcode. For this, let's first set up a dynamic name reference for the team member, just as we did before for the type. Call it team member, scope is this worksheet, and to make it dynamic, we're gonna remove the $sign again. And then to look up the respective row, we define an index match formula that is wrapped in an if-NA function. The return array is the shortcode column of the project team member list. And to get the correct row, we apply the match function to look up the team member in this name column as an exact match. In case this returns an NA error, let's just return an empty string again. And once we add this formula to all the rows using autofill, we see that this perfectly works. Let's just decrease the font size and change the color to a gray tone. And also add some indent. We can even increase the size of this column a little bit. And now this is an almost perfect implementation of this team member and role assignment. There's only one last thing that I want to add to this feature to make it fully complete. For this, I jump back to the settings worksheet and I see at first we need to delete one column here to make the Gantt button come back to its original place, as we obviously have added one additional column in the process. Okay. Now the thing I want to add is a user-friendly way of removing team members from the project, which might happen from time to time. Removing a team member like Lin here is no problem. But what if the team member you deleted here is currently assigned to an item in the Gantt worksheet? Well, you see the role is empty because the lookup results in an NA error, but the name is still written in the cell. So I think it is very helpful to visually indicate that this team member is no longer part of the team and the item potentially has to be reassigned. So my idea here is to add a conditional formatting rule that checks if a match function lookup of that name in the name list returns an NA error using the isNA function. And if that is the case, we change the font color to a warning red. Exactly like this. So now when we add this team member back to the list, there is no warning. And once this team member is removed again, we get the indication that we might need to reassign this item. Amazing! Now that we have set up the full item details section, let's start implementing the basic manual planning with independent start or end dates. The most crucial columns for the actual plan will be these two calculated columns for the start and end date, because all the date-related visualization in the chart area will be based on these two columns. The reason why the start and end date need to always be calculated is that we're gonna have different input options. As previously mentioned, the calculation of the start and end date will always be based on two inputs. One input is the number of required workdays, and the second input is either an independent start date, an independent end date, or a dynamic start or end date that is dependent on another item. Of these two calculated start and end date columns, one will always be defined directly from the date section, and then the other one will be calculated based on that and the defined number of workdays. Before we start setting this up, let's make sure that all the date columns, including the base plan columns, have the same clean date format. I prefer this custom date format, and for the workday column we make sure that the content is aligned to the center. Let's start with setting up the simplest of all options, which is providing an independent start date and the number of required workdays. In order to make these cell values easy to reference in other formulas, we define dynamic name references for the independent start date. Always keep in mind to remove the $ in front of the row number. And then we do the same for the workdays. But this time we not only make it dynamic, but we also want to make sure that this name reference will always have a default value of 1 in case the cell is empty. We can easily do that by returning the maximum of the cell value and 1. This has two big advantages. First of all, it is guaranteed that an item will become instantly visible once either a start or end date is provided, even before the number of workdays is entered. And second, we don't need to actively enter a workday number for milestones, as we will need to reference the calculated plan start and plan end for the Gantt chart visualization. Let's also add dynamic name references for these. I explicitly call them plan start and plan end, as these will be the ones that will always represent the actual plan in one constant place. Alright, the formula for the plan start in this scenario is pretty simple. We first check if the independent start date is non-empty, and if that is the case, we return the independent start date, otherwise an empty string. So this is the date directly taken from the input section, while the plan end date has to be calculated based on the plan start and the workdays. In a similar manner, we also check if int start is non-empty, because only then the plan start is also non-empty. And then we're gonna make use of the workday function, put in the plan start as start date, and add the workdays -1. So in this example, 9 workdays to this plan start. The reason why we have reduced this number by 1 is that the plan start date is already one of these 10 workdays, so the plan end date is only 9 workdays later. The alternative value in case int start is empty is again simply an empty string. Let's do a quick check if the calculation is correct by looking at the timeline. As you see, the 10th to the 21st of May are exactly a 10 workday time span, so it works correctly. When we take a closer look at this formula, there are two crucial things we always have to keep in mind. First, every time we calculate one of these plan dates by adding or subtracting the workdays from the other date, it is crucial that we're going to reference the other calculated plan date and not the input date, like int start in this case, directly. Because otherwise we're gonna end up creating circular references at some point. And the second aspect to consider, as both these formulas will get a lot more complex over time and also gonna reuse certain calculations, it is advisable to transform all sub-calculations in here into what I call named calculations. What that means is that instead of entering these sub-calculations directly into the formula itself, we're gonna create names for them in the name manager and only have to reference the name in the bigger formula for the same exact result. That not only makes the bigger formulas easier to read and the sub-calculations reusable, but also allows us to manage and potentially adjust each sub-calculation at one central place in the name manager. Now let's use this to manually set up the schedule for the tasks and milestone of this stage. As you see, as soon as we have entered the independent start date, the plan start and plan end are instantly displayed as the workday's value is set to 1 by default. And for the milestone, we only need to enter the independent start date and can leave the workday cell empty because we want the milestone to start and end on one particular date. Perfect! With this example schedule set up, we can now create the default visualization in the chart area right below the timeline. We have all the information prepared that we need to decide if an item is within its plan in a given cell, because we now know what the plan start is, what the plan end is, and what the respective date in the timeline is. These name references work correctly from every cell in this chart area, no matter which one you take. To figure out if a cell should display something or not, all we need to do is check if the date is within the planned time span. So if the date is greater equal the plan start and smaller equal the plan end. This formula returns either true or false, and for demonstration purposes, let's display that as either a 1 or a 0 by multiplying it with 1. We can use the autofill handle to add this formula to the whole row, and as you see, this displays a 1 in each cell belonging to the defined planned time span. When we add this to all the rows, we can verify it works perfectly for all the defined items. Amazing! For this formula again, it makes sense to transform it into a named calculation. So let's copy it and create a new name that is called item in plan. Set the scope to this worksheet and paste the formula. It is simple as that. Now we can replace this formula and have one short expression that works in every cell of this Gantt chart area. And that is all we need to implement the default visualization. One big goal of this template is to have the stages, the tasks and milestones all differently visualized, and while the stages and tasks can be perfectly visualized using a cell color fill without any written cell content, we want the milestone to display an actual milestone symbol. For that purpose, I have prepared two Unicode icons, this one for an open and this one for a completed milestone. And for now, this symbol for the open milestone has to be somehow written into the cell. So let's copy over this Unicode icon and start building the milestone visualization as an in-cell formula. In the formula, we only have to check two conditions that have to be true. First, the type has to be a milestone, and the item has to be in plan in this cell. If that's the case, we just print this milestone symbol, otherwise an empty text string. Let's add this formula to the full range. we instantly see the milestone symbol is printed on the correct day. And in addition, we're going to align the cell content to the middle and center and slightly increase the font size. Perfect. For the stages and tasks, on the other hand, we want to create Gantt bars by filling the respective cell backgrounds with some color. And for that, we can directly jump into the Conditional Formatting Rule Manager and create 2 new rules. Let's create a default rule for the stages. Just like for the milestones, this formula checks if the type is a stage and if the item is in plan in the respective cell. If both these conditions are true, we want to add this darker gray background fill color to the cell. Let's apply this rule, and you can see the stage is now perfectly visualized as a dark gray bar. So let's move this rule down in the rule order, which simply means that this rule is now applied after the 2 other rules. And then we duplicate this rule to create a similar rule with a lighter gray for the tasks. Once we apply this rule, both the stages and tasks are now beautifully visualized. The only thing left now is we also want a similar gray coloring for the milestone symbol. So let's jump back to the Conditional Formatting Rules Manager, duplicate one of these 2 rules, then change the type condition to milestone, and this time we don't want to control the cell fill, so we clear that first. Instead, we jump to the Font tab and change the font color to this darker gray. I decided to make this milestone symbol color match the stage color to better stand out. And once applied, now all these type visualizations are in perfect harmony. Beautiful. Now, before we close this Conditional Rules Formatting Manager, I need to show you 2 concepts in here that are crucial in terms of worksheet efficiency. At first, always add a check in this Stop If True checkbox if a rule and all the following rules are mutually exclusive. What that means is, in this case, if the stage coloring rule here is applied because its conditions are true, then the 2 following rules don't have to be checked because they cannot be true at the same time. That will save you a lot of computational resources, especially with a larger number of rules in here. And the second concept somehow builds upon this Stop If True feature and is even more crucial. When we take a look at these default coloring rules, we see that each of these does the same item in plan check. That is super inefficient as we do the same condition check over and over again. And to avoid this, we can add one additional rule that does this item in plan check once at the beginning, and only if the cell passes this test, we continue with looking at the following rules. That's why I call this a stopper rule, because what we do in this new rule, we're gonna check the opposite of the condition that we want to be true. So in this case, we check if not item in plan. We don't need any formatting here, just click OK, place it right on top of these coloring rules, and then activate that Stop If True checkbox. So now if the item is not in plan in a cell, the following rule conditions won't be checked because it is not required. And this stopper rule now allows us to simplify the coloring rules by removing the item in plan condition. And that leaves us with the type check here. And now this whole setup is super efficient and we are perfectly prepared for scaling this with some additional coloring rules later. Great! Now that we have set up the default visualization, let's take a look at the other manual scheduling option, which is instead of entering an independent start date and doing a forward scheduling, entering an independent end date and doing a backward scheduling. Let's reproduce the same exact time span for this stage by entering the end date that is calculated in the plan and cell at the moment, which is the 21st of May. At the moment, the plan start and plan end formulas are only able to work with the independent start date input, and that's why they now show nothing but an empty cell and the visualization is also gone. But we're gonna change that in a second. First, we're gonna create a dynamic named reference for the int end date. And then jump straight into these formulas. This time we start by modifying the plan end formula at first. Instead of returning an empty string if int start is empty, we now continue with a second if statement that checks if int end is non-empty. Because if that is the case, we want to directly get the value of int end, and only otherwise we're going to return an empty text string. That works like a charm, so let's also update the formula in the other rows of that column. And as you see, this time the plan start has to be calculated backwards based on the plan end. So let's add the same logic here. First, checking if int end is non-empty. And if that is the case, use the workday function. Put in the plan end as the start date of that calculation and then add a negative number of workdays. So we multiply the workdays by -1, and since the end date is already one of these 10 workdays, we have to add 1 again to make it only go back 9 workdays. And otherwise, if int end is empty, we just return the empty text string. We now have successfully reproduced the exact same time span that we had before. So again, let's take that sub-calculation and create a new named calculation that we call plan start calculation. Let's update the other rows in the plan start column and test if it works in the other rows just as fine. And as you see, we can easily recreate these time spans by providing only independent end dates. That's amazing. We have intentionally implemented both these formulas for the plan end and plan start using a hierarchical logic. That means these formulas are written in a way that the int start value will always override the int end value. So once we enter an int start value, the int end value will just be ignored. That is really important as it makes sure that there is no confusion which value is taken if multiple input dates are provided at once. However, at the moment this logical hierarchy is not instantly obvious when only looking at the int start and int end columns. So what we do to make this super intuitive is we're gonna add a conditional formatting rule to the int end column that simply checks if int start is non-empty. Because if that is true, then the int end value is basically inactive, not used, and we indicate that by giving it a mid-gray font color. There we go. Now when I enter an int start date, the respective int end date is automatically grayed out, and I instantly know which one of both is currently active. Let's override the stage and task items with the original int start dates. Leave the milestone defined via the int end date, and then we quickly set up a plan for the second stage with the stage and the first task using a forward scheduling, and the other two tasks being backward scheduled. Here you can perfectly see how the bar now grows backwards as soon as we set the number of workdays to a number that is bigger than 1. Same for the next task. And for the milestone again, it is enough to only provide a date. Great! Now it's the perfect time to show you how you can quickly automate the stage calculations and visualization based on its items. As we have no intention to overwrite the calculated plan start and plan end formulas, the clean approach here is to work with some simple formulas in the input section. For that, I have prepared two standardized placeholder formulas that are super easy to use. All you need to do is copy this formula into the int start cell of a stage, and then replace this placeholder with the planned start range of the items in that stage. And in the same manner, we can dynamically calculate the number of workdays using this placeholder formula, which references the planned start and then calculates the net workdays between this planned start and the maximum of these items' plan end dates. We are now free to change any of these task or milestone schedules. The stage time span will always be automatically updated. That is amazing, but I think the usage of formulas in these input cells somehow makes it necessary to highlight an input cell whenever a formula is used. So for that, let's add a new conditional formatting rule to that int start column that checks if the cell contains a formula. Let's make the cell reference fully relative. And the formatting I think that makes sense in this case is this strong blue font color, because this is a color that we are commonly familiar with from links, for example from websites or documents, and in a way these formulas link to other cells. Let's also include the workdays column into this rule, and that makes these formula inputs clearly distinguishable from regular input. Once we have used such an auto-stage formula in one stage, we can simply copy it over to another stage since the range reference is relative. It just perfectly covers all these included items directly. In case you have a different number of items in that other stage, all you need to do is adjust this referenced range with your mouse and you are good to go. And the same for the auto-stage workday formula. What is really amazing about this general setup, we can now collapse the date input columns and have the workdays as key information still visible. And now whenever we adjust the number of required workdays for a task, there is no need to manually update the stage workdays as they are updated automatically. As this auto-stage workdays calculation is not simply adding up all the workdays of its items, but actually computing the maximum time span of all items, it is fully able to handle whenever items overlap within that time span. Eventually, while for the auto-stage workdays it makes sense to display the actual number, I think for the auto-stage int start value, we can make it even more obvious that this is not a real int start date by adding an additional rule that only focuses on this column and is also limited to stage rows only. So whenever a cell is in a stage row and is a formula, instead of displaying the date itself, a really cool trick is to just override it with a text value. So no matter what the date is, it will display the text auto. Let's set the text alignment to center. And I think that is a beautiful and intuitive setup. This manual planning with independent start or end dates is pretty helpful, but it is nothing compared to what we're gonna build now. Because now we're gonna add the core feature of this template, which is an intuitive and super powerful dependency engine that allows you to make your project plan fully dynamic. We're gonna implement all 4 possible types of dependency connections that you can have between items, so this step will transform this Gantt chart from a good-looking project visualization tool into a professional project planning tool. This right here is the section that will allow you to quickly create all kinds of dependency connections between items. We're gonna build up the whole dependency logic based on the second task P2. Now, instead of relying on one of these manually defined independent dates, we're gonna make that task dependent on task P1. So let's clear all these inputs for the subsequent items, remove the independent end dates, And since we want to make this task P2 dependent on the task P1, we're also going to remove the independent start date for this one. The workdays can just stay in there as we're going to use them in the same way as we did before. Let's also temporarily move the timeline 1 week to the right, so that not only the forward-looking dependencies, but also the backward-looking dependencies are instantly visualized once they are implemented. The key idea for making an item dependent on another item is that you will have to link to the other item's ID. This obviously requires us to create a reliable ID system in advance. And for that, we start by defining a dynamic name reference for the cells in this column. Call it ID, set a scope, and as usual, remove the $ in front of the row number. As we don't want to manually enter any IDs, we somehow need them to be automatically created and self-sustaining in case we insert or delete a certain row. That means we want to have an ID system in which each ID dynamically represents the position of its items row in the whole list of items as a unique number. The straightforward solution of simply entering and autofilling a sequence of numbers directly is not sufficient in that case, because as soon as we insert a row and use the fill down option, we get duplicates in here and would need to manually update all the subsequent IDs again. In the same manner, setting the first ID to 1 and then for all subsequent IDs just referencing the previous ID and incrementing it by 1 is also not fully working, as the ID below the inserted row unfortunately keeps referencing the same ID. In addition, both of these very simple solutions would get absolutely destroyed as soon as you delete the initial row. So we have to create something that is way more robust and self-sustaining. The key for achieving that is to give each cell all the information about the previous values in its column. We can easily create a named range that we call prev_col range, short for previous column range, and define it as a range starting from the header cell and ending at the cell right above. At the moment, this is a fixed range, but removing the $ in front of the last cell's row gonna make this a range that will dynamically grow and shrink depending on the cell from which it is referenced. Furthermore, as we might make use of this in other columns as well, let's also remove the $ in front of the column's letter. Whenever you have defined a name that refers to a range or cell, you can easily check what it is currently referring to by opening the name manager, selecting the defined name, and clicking into the formula below. You see, with this cell selected, it refers to the exact range that we need. The reason why we included the header in here is because that ensures that even if we insert a row on top of the initial row, it will become part of that range and not be excluded. Now we can use that to enter the formula that will dynamically create the correct ID for each row. In this formula, we first need to check if this is the initial row in the list of items. That's the case whenever the row of the cell itself equals the row of the header plus 2. 2 because we have this separator row in between, so the initial row will always be 2 cells below the header cell. If that is the case, the ID has to be 1. And for all the subsequent cells for which that is not the case, we simply compute the maximum of the previous column range and increment it by 1. Simple as that. Let's drag the autofill handle down to add it to all rows in this column, and that looks good so far, but the actual power of this becomes visible once we insert a row and fill the values down. You see, all the ID values get perfectly updated to correctly represent their new position in the list. Even if I would insert a row above the first row and use the fill up option, it is also correctly updated. So that gives us an automated and robust ID system that is not instantly destroyed whenever we forget to manually update it. Now we can jump over to the dependency section and make task P2 link to the ID of task P1. This link should always be created by actually referencing the respective ID cell in order to make sure that the linked ID number is correctly updated in case the other item's ID changes due to an inserted or deleted row. To help you instantly see if the linked ID is an actual cell reference and not just a fixed number typed in, we make use of the conditional formatting rule that gives the cell content a blue font color in case it contains a formula. We increase the range by adding a comma and selecting this column. And now this referenced ID is colored blue, which tells us it links to another cell. A super powerful advantage of referencing the other item's ID is that it couldn't be easier to make this task dependent on a different item, because you can simply click into the cell and drag the reference to another ID. Okay, now that we have found a way to create a robust link to another item's ID, let's make this cell value dynamically referenceable as d.id, where the D stands for dependent. And the initial thing that we want to do with this ID is to extract some fundamental information about the other item. The first information we are interested in is the position of the other item. So is it positioned above or below this item's row? This information can be really helpful as an indication for either a forward scheduling dependency or a backward scheduling dependency. And to indicate that visually, we're going to make use of these two Unicode arrow icons. The formula for this is quite straightforward. At first, we check if d.id is non-empty. And if that is the case, we only have to check if d.id is smaller than this item's ID, which means it's positioned above this item, and we insert a placeholder for arrow up. And alternatively, in case did is greater than this item's ID, the other item is obviously positioned below this item, so here we want to display the arrow down. And as fallback option, we just return an empty text string. Let's jump to the Unicode icons and copy over the arrow up, paste it to replace the placeholder, and then we do the same for the arrow down. Perfect. Let's also decrease the font size, set the text alignment to center, and adjust the size of the column. And that gives us a beautiful indicator for the position of the linked item. In the next column, we want to automatically display the type and name of the linked item. This is a classic lookup problem, so we can use the match function to look up did in the ID column to get the correct row number, and then use the index function to return the respective value from either this or this column. As we're gonna need the row number of the other item at multiple occasions, let's just start with the match part and make it a named calculation. For the lookup value, we pass d.id. Then for the lookup array, we can pass the whole column B as an absolute reference with $signs, and we need to have an exact match. This returns 16 in this example, which indeed is the row number of the linked item. So let's copy that formula and transform it into a named calculation that we call d.row. Perfect. For extracting the other item's type, we use the index function to take a look at the column E and return the value from the row calculated in d.row. That seems to work correctly. Let's change did to reference the milestone. That also works like a charm. So we can save this calculation as d.type. And for the linked item's name, it's basically the same approach. Let's call it d.name. Paste the formula we just used and replace column E with column F. Now we have both these information about the other item available as a named calculation. Let's also decrease the font size a bit and change the font color of all these information to this dark gray to show these are secondary lookup information. And now we can create a concatenated string that contains dtype in brackets, followed by dname. Amazing! But once we add this to some rows that have no DID reference, this will result in an NA error. So in order to catch this and potential other errors, let's wrap this expression in an if error function. One additional aspect to consider is that the other item's name could potentially be way longer, like this for example, so the extracted text in the D item column would extend into the subsequent columns. And to avoid that, I recommend to adjust this formula. Instead of just directly printing the full name, we're first going to check if the length of this name exceeds a certain threshold, for example 7 characters. And in case it really exceeds that threshold, we're going to apply the left function to extract the first threshold number of characters, so in that case 7, followed by some dots. And otherwise we can simply print the full name. So now this long name is cut off at exactly that threshold, and once we increase the column size a little bit, everything now perfectly fits in. And as soon as that threshold is not longer exceeded, the dots disappear correctly and we have the full name displayed. Perfect! Let's do a final test for the whole D item output by changing the referenced ID once again. And the information we get are exactly those that we expect to see. Great! Let's move on to the heart of the dependency engine, which is the selection of the type of dependency connection we want to have. In the column d.con, we add a drop-down list that lets us select one of 4 different connection types: finish to start, start to start, start to finish, and finish to finish. The first letter always refers to the other item and the second letter to this item. So finish to start means that this item starts the next day after the other item has finished. So the planned start date of this item is determined by the planned end date of the other item. And as this makes the planned start tied to another date, an increasing number of required workdays will make this task grow forward. Start to start means that this item starts the same day the other item starts, so this item's planned start is tied to the other item's planned start, which also means it grows forward with an increasing number of required workdays. Start to finish now means that this item has to finish right before the other item starts. So this time the planned end date of this item is tied to the other item's planned start date, which means an increase in required workdays makes this item grow backwards. And eventually finish to finish means that this item finishes the same day the other item finishes, so this item's planned end date is tied to the other item's planned end date, and with an increasing number of required workdays, it also grows backwards. A great way to provide some basic information and instructions for an input column like this is to select the header cell, then open the data validation window without adding an actual data validation. What we are interested in instead is the input message tab, which allows us to enter an informative message that is displayed whenever this cell is selected. I'll just enter some basic information about the 4 dependency connection types. And now this information is available here whenever I need it. The column next to this will allow us to define a lag, by which we want this item to be shifted to the right in case we have a positive value, or to the left with a negative value. Let's set the text alignment to center for both these columns. Adjust the column size. And create a dynamic name reference for both these columns. We call the first one d.con and make the row relative, and then we do the same for d.lag. With this, we now have all the values and information available that we need to make this dependency logic part of the plan start and plan end formula. I hope you remember the hierarchical logic that I talked about earlier, which basically was that both the plan start and plan end formula always start by taking a look at the int.start value, and only if that cell is empty, they consider the int end value, and only if that cell is also empty, they will now consider the dependency section and do the date calculations based on what is in here. So let's start with the plan start formula and replace this empty string with a completely new expression. What we need to do first is to check if d.id is non-empty. Otherwise, there is nothing that could be calculated here. And in case it is non-empty, then we can take a look at what connection type is selected. For the plan start formula, we are only interested in those dependency connection types that will make the start date tied to the other item. The first one of these is the classic finish to start dependency. In that case, we want to do the respective calculation, for which we simply enter a placeholder for now. And alternatively, if the selected dependency connection type is start to start, we want to do the respective start to start calculation. In case it is one of the other two dependency connection types, then we know that the plan end date will be tied to the other item's date, and we need to do the backward calculation based on the plan end date and the number of required workdays. And guess what? This is something that we have already defined as the plan start calculation. What a great coincidence! Now we only have to close these brackets for the last two if statements, then provide a fallback value in case did is empty, and eventually close that bracket as well. For now, with finish to start or start to start selected here, the respective placeholder appears correctly, and once we select one of the other two types, we get this value error because right now the formula assumes that the plan end date is already available, which is not the case yet. To catch these errors in general for this huge formula, let's wrap it inside an if error statement just to make sure it will always display an empty string in such a case. For the plan end formula, we're gonna implement the same exact pattern. Instead of returning an empty string here, we first go to check if d.id is non-empty. And if that is the case, we now check if d.con equals one of the other two dependency connection types, which are start to finish and alternatively finish to finish. Otherwise, in case it is one of the other two values, we need to calculate the plan end based on the plan start and the number of required workdays, which is already covered in the plan end calculation. Let's close both these if statements, enter a fallback value in case d.id is empty, and we can also directly wrap the whole formula in an if error function to catch potential errors. The basic logic of when to do which calculation is now implemented. When switching between different values of dcon, the placeholders perfectly show us which of the plan start or plan end is the one that is calculated based on the other item. This allows us to proceed with replacing these placeholder calculations with some actual calculations. And for the beginning, we're going to remove this lag value here to avoid any confusion. For the finish to start calculation, we need to set the plan start date to the workday after the plan end date of the other item. So we want this date to be one workday after this one, plus a potential lag. The workday function is the one that allows us to do exactly this calculation. We only need to somehow grab this value, but as we already know the row of the other item, we can simply return this value using the index function by entering column T as the return array, and d_row as the row. With this, we now have a start date defined in the workday function and only need to specify the number of workdays we want to add to this date. As for this finish to start dependency connection, we are looking for the next workday plus a potential lag. We're going to enter 1 plus d.lag and close the workday statement. At first glance, it seems to perfectly work. The plan start is correctly calculated, and thus also the plan end can be calculated based on the plan start and the workdays. When we add a lag to this dependency connection, the second task is shifted to the right or to the left accordingly. And the most important aspect, when we change the duration of the first task, the plan dates of the second task are updated correctly, so that the second task always starts right after the first one has finished. Perfect! For the start-to-start calculation, we can now simply copy over that formula, as we only need to do some tiny adjustments. For this one, we want both items to start together, so this time instead of grabbing the other item's plan end date, we now need to grab the other item's planned start date from column S. And for the days argument, we're gonna remove the 1, because by default it now is not the next but the same day that we want to have, and we only want to shift it by a potentially given lag. When we now make this a start-to-start dependency connection, both items perfectly start together. Changing the other item's duration in this example has no impact, but changing the other item's independent start date makes both perfectly move together. For a better maintainability and less complexity in this huge formula, let's transform both these expressions into named calculations. The first one will be called FS calculation. And the second one accordingly, SS calculation. And that way we have now transformed this huge amount of calculation logic and functionality into a relatively small and understandable set of commands. Let's jump right over to the plan end formula, because here we're now going to create similar expressions for these two dependency connection types. For the start to finish calculation, we now want to have the plan end date of this item 1 day before the planned start of the other item, plus a potential lag of course. That means we're gonna make use of the workday function again, and as the date to start with, we're gonna grab the other item's planned start by applying the index function to column S with d.row as the return row. And since we want to calculate the workday right before that date, we add -1 this time, plus the potential value in d-lag. Let's close that statement, hit enter, and change the dependency connection to start to finish. And it works like a charm. When we change the start date of the other item, both items perfectly stay tied together through this connection. And also adding a positive or a negative lag works just like it should. Eventually, for the finish to finish dependency connection type, let's copy over this expression. And you probably already know the adjustments we're gonna make. We're gonna remove the -1 and grab the other item's date from column T instead of column S, as we need the plan end date. That way, both items now will finish together on the same day, but potentially shifted by a given lag. This also works as it should. Now both plan end dates are dynamically tied together. Adding a lag value also produces the wanted result. And now we can transform both these new expressions in the plan end formula into two named calculations. The first one called SF calculation, and the other one accordingly, FF calculation. Let's insert these named calculations instead of the full formulas and do a final checkup if everything still works correctly. That looks pretty good. In this whole dependency logic, there is only one thing that we haven't considered so far, and that is what if no dependency connection type is selected, so the cell here is empty. With the given setup, that will result in a circular reference, which is why we get this warning. And the reason for this circular reference is both the plan start and plan end formulas try to calculate their dates based on each other, as neither of them is able to find one of their two relevant dependency connection types in there. So the plan start calculation and the plan end calculation are executed at the same time. The good news are, we can easily avoid this by setting a default value in case d.con is empty. In my opinion, finish to start is the most intuitive choice here, and the quickest way to make this the default value is by saying apply the finish to start calculation for the planned start, either if dcon equals fs or d.con equals nothing, so an empty string. That way, finish to start is always the default choice in case no different value is selected. We now have successfully built the whole dependency logic, so we can decrease the height of this formula bar up here again, update all the cells in the plan start and plan end column with the newly built formulas, do the same for the D item columns, and since finish to start is the default value in the dependency calculation, I suggest to just paste it as an actual value for all cells by default, and then make these columns behind the DID column invisible as long as no DID is referenced. We can achieve that with one simple conditional formatting rule. This rule will check if DID is empty, and in that case sets the font color to white. That way nothing is visible as long as DID is empty, and both the D item and the dcon value magically appear once we put a reference into the DID column. In my opinion, that makes the user experience way better. Eventually, let's remember the logical hierarchy for which input date to consider that we have built into both the plan start and plan end formula. With these updated versions of both formulas, the dependency functionality has the last place in this hierarchy, which means it is overwritten by both the int end date and int start date, just like the int end date is overwritten by the int start date. For the dependency connection, this means it becomes inactive if at least one of the int start or int end date is non-empty. So let's add the same graying out conditional formatting to the dependency section as we already did for the independent end date column. This rule checks if at least one of the int start or int date is non-empty. In case that is true, we set the font color to this mid-gray, and we can see as this rule is currently executed as the top rule, it makes the dcon values appear again. So let's just move it below this rule here that ensures the font color is white if DID is empty. We click apply again and the problem is solved. Great! Let's do some example planning with the dependency engine for all the items that we have set up so far. We're gonna make this task dependent on the preceding task with a simple finish to start dependency and see how the task has one workday by default, and as soon as we enter a number higher than that, it grows to the right. In a similar manner, we could now make the milestone dependent on that last task in that stage by referencing ID 4. But in cases like that where we simply want to have consecutive item dependencies, there's a beautiful shortcut you can use, which is the autofill function. Simply select the d.id of the preceding item and then drag this autofill handle down, and since this is a relative reference in there, this autofilled reference now links to the next ID, which is 4. For milestones, I generally prefer a finish-to-finish dependency, as a milestone is often logically tied to the successful completion of one or multiple tasks. For the second stage, we can start by copying over the auto-stage formulas because we already know the amount of items in that stage. In case that stage had a different number of items, we could easily just click into the formula and adjust the referenced range to cover all of the items. And the same for the auto-stage workday formula. Using this stage, I want to demonstrate how you can easily make a stage dependent on another stage. For example, with a finish to start dependency connection, all you have to do is to determine which one is the initial item in the second stage, then link this item to the first stage, and make the subsequent items directly or indirectly dependent on the initial item. For consecutive dependencies within the stage, we only have to link the second item to the first one, and then we can use the autofill function to create consecutive dependencies for the last two items. Let's change the milestones dependency connection type to finish, and enter the number of required workdays for the tasks. See how easy that was? Both these stages are now tied together, and every change that impacts the first stage's plan end date, like for example an increased duration or change in dependency structure within that stage, will make the second stage automatically adjust its schedule accordingly. Now that was a classic forward scheduling dependency connection between stages, because we have made the start of the second stage dependent on the other stage. We can also create a backward scheduling dependency for these stages by making the plan end date of the second stage dependent on the other stage, for example as a finish dependency. That would mean the stage end date is fixed, and every increase in duration of this stage would make the stage grow backwards. To achieve that, we have to reverse the dependency logic in that second stage. Initially, we determine a final item in that stage, in this case this would most likely be the milestone, then link this final item to the other stage, and make all the